All right, let's get straight into it. We're going to crack the code on a classic AQA GCSE chemistry question. And the key? We're going to use the official mark scheme. This isn't just about finding the right answer. It's about seeing exactly what an examiner wants to see to give you those top marks. So let's dive into question 04 and see how it's done. Okay, so here's the game plan. We'll kick things off by getting inside the examiner's head. Then, we'll blast through some quick-fire questions to build momentum. After that, we'll nail down a key definition, crunch some numbers, unravel a famous discovery by Chadwick, and finally, put it all together into the ultimate perfect answer blueprint. Sound good? Let's go. So, before we even look at the answers, we need to talk about our secret weapon, the mark scheme. This thing is gold. It literally tells us the exact words and numbers the examiner is looking for. It's like having the answers and the rules to the game. Let's see how this works for question 04. First up, we've got the first 3 parts of the question. These are your multiple choice questions, and you should think of them as quick wins. You get these right, and you're building confidence and momentum for the tougher parts to come. For these first few, the mark scheme is super clear. For 04.1, the answer is B. This is one of those fundamental facts that you just have to know. No charge on a neutron, easy mark. Moving right along to 04.2, the correct choice is C. Again, another core concept. Protons are right there in the nucleus. Bam, another mark in the bag. And to wrap up the easy ones, 0.43, the answer is A. This is testing your knowledge of the subatomic particles, and the electron is by far the one with the smallest mass. And just like that, boom, 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 3 marks secured. You're off to a great start. Okay, now we get to our first written answer. This is where things get interesting, because your wording has to be spot on. The question asks for the definition of mass number, and precision here is absolutely everything. And there it is. Those are the magic words, right there. The perfect 1-mark answer is simply the sum of protons and neutrons. That's it. You write that down, you get the mark. No more, no less. It's that simple, but you have to be that precise. Now, here's a little insider tip. Straight from the mark scheme, it actually gives you a bit of wiggle room. It says that saying number of protons and neutrons is also totally fine. So whether you say sum of or number of, either one gets you the point. All right, let's get our calculators out for question 04.5. This one's about calculating the relative atomic mass. Now, what's really important here is that the mark scheme isn't looking for one single perfect number. Instead, it gives you a target range to hit. And here's that range. As long as your final answer is somewhere between 69.5 and 70.0, you get the full mark. This gives you a little bit of flexibility for how you round your numbers during the calculation. So just get in that zone and you're golden. Okay, here we go, the 2 marker. These are huge. You've got to make sure you get both points. The mark scheme is super helpful here because it shows us that this is a classic 2-part answer. Let's break down how to get both. Part 1 is just stating the fact. Simple as that. You need to say that Chadwick's big contribution was proving that neutrons existed. You write that sentence down, and you've just locked in your first mark. This is where so many people stop and only get 1 mark. To get that second point, you have to explain why his discovery was so important. And the keyword here is isotopes. You have to connect the dots and explain that we needed neutrons to understand how isotopes could exist. Atoms of the same element with the same number of protons but different masses. Chadwick's discovery was the final piece of that puzzle, and explaining that link is what gets you that second mark. And check this out. The mark scheme even gives you other ways to say it. You could say his work was needed because isotopes are atoms of the same element, or you could say it's because they have different numbers of neutrons. Any of these explanations makes that crucial link and gets you that second precious mark. So let's put it all together now. We've seen what the mark scheme wants for every single part. We can now build a cheat sheet, a perfect blueprint for a full mark answer to all of question 04. And here it is, the whole shebang. B, C, A for the multiple choice. The exact wording for the definition. That target range for the calculation. And that essential 2-part structure for the final question. This, right here, is what a perfect answer looks like. So you see, the big takeaway here is that the mark scheme is so much more than an answer key. It's a window into how examiners think. It shows you the patterns they look for. The precise wording, the acceptable ranges, the 2-part structures. Learning this is just as important as learning the chemistry itself. And that's a wrap on our breakdown of question 04. This whole method, using the mark scheme as your guide, is a total game changer. You can apply it to literally any question on any paper.
to figure out how to turn what you know into marks on the page. So the only question left is, which one are you going to analyze next?